All right, so I'm going to show how we're going to deploy an instance of the current GitLab Observability tooling. And to do that, I've checked out a version of the Opstrace repository. I did a git pull, some in the latest, yes, I'm up to date. First things first, we need to do a local cluster. So let me see, I'm going to go to the quick. I know these by heart. I'll do them by heart. And there's a quick start for anyone to do these. So basically first, sorry, Mac. So basically first, we're going to do make to create do make kind, because we're deploying this on a local cluster. So I've already set up my Mac and I've already given enough RAM and enough CPUs for this cluster to work, but that's also described in the click start. The other thing is, I think the whole end-to-end system on my machine will be a bit quicker than if somebody tries to replicate this, because I don't have to pull any images anymore or anything like that. So yeah, so right now it's starting the kind cluster. Once the kind cluster is started, I'll have a local Kubernetes cluster to be able to build and deploy this Opstrace stack against it. So let's wait for a bit. There we go. Okay, now we have a working cluster. We can check just to make sure. Oh, first time, always a bit slower. All right. And then we are going to, sorry, I cleared my screen. And then I'm going to do a make deploy. Make deploy is going to build and deploy the system. And so that means a whole build and deploy. What's going to happen is basically we have we're building an operator. That operator, once built, gets deployed to the Kubernetes cluster, and that operator will then deploy the rest of the infrastructure. So that's what's happening here. So since I did a git pull, I have a couple of fresh dependencies. And now the build is done, so we can see that it's applying and applying things to the Kubernetes cluster. So everything that's getting created right now, like what you can see, especially in the part here, this one is we've created what's called custom resources for this cluster. So we can now deploy tenants, we can now deploy dashboards, we can now deploy, there's a bunch of different systems that we can deploy to one cluster. So now that all of this is done and deployed, the next step is to the next step will be to create a config file. That config file is here. I've already created it. It's called cluster YAML. I've also created inside of my own. So now I'm sharing my secret, but that's fine. I'll change it right after this video. But basically, inside of my profile here, inside of API, I've created an API. Where is API? API. Where is API? I don't remember. Applications here. So in applications, I've created. Now it's a bit slow. Right when I wanted it slow. It's okay. Okay, so I've created an application. It's down here. It's an application called Opstrace. I've added a callback. Everything is in a quick start, like I explained, and that gives me that gives me a client ID and a client secret to put in there. This shared secret is just a random string right now, will be used in the later future, so don't worry about that one. So now that I have this cluster YAML, this is basically the definition of a cluster. when you put this inside of this Kubernetes cluster, a new cluster will get created, a new Opstrace cluster will get created. So basically, we're going to, sorry. We're going to kube control apply this YAML file. So what's doing? So as soon as we've done that, see, it's created one thing, which is something called a dev cluster, which is what I've currently deployed. Now we can actually wait, and we're going to basically wait until this cluster is ready. That's one of the nice things of custom resource definitions and operators. You basically, the operator tells you when everything is ready. You don't have to go hunt for things. We can take a look because we're curious. We can do a get pod, and we can continuously look at the output of what's happening here. And you can see that the cluster is getting created. See, all of this is the basics that are already installed inside of the cluster that we did when we did make deploy. So it's all our operators and a few other things like a development Postgres and things like that. We can see now that we have our first one running here. And now the pods are getting created. So this is the longest part of the setup, I would say. This is the part where our code is actually getting downloaded, deployed to the system, and deployed inside of the Kubernetes cluster. So yeah, it's going to be a few minutes. So if this was a live demo, there'd be questions right now. Do you have a question, Nicholas, since you're here?
Yeah, I was trying to think if I have any questions right now. So if this was not local, how would it be? I guess, how would this?
Exactly the same thing. So we used a kind cluster because that's easier to develop locally and everything. But if you deploy a Kubernetes cluster in the right configuration, which is what our Terraform code does, right? Like then you can deploy the same system and code to that cluster and run it there, right? Like there's not a big difference. More and more things are getting deployed. There's a lot of dependencies, right? Like Redis is used and other things like that. Things could get much faster because right now things are spun in sequence. It's easier for debugging. It's easier for development in the beginning. One day when we're more confident, we can start spinning up a couple of things in parallel and take a look, maybe everything. In theory, you can spin up everything in parallel, and it just starts. This is how our previous code worked, but this is a better approach right now for development. Like we're going to find bugs faster this way. Yeah. Just a few minutes. And once we're done, once this is done, we'll be able to have a bit more of an interactive part to the demo. So yeah, this is clearly separated in two parts, right? Like this part of the demo is the part where I would say the operator, the person who is going to deploy the system deploys it, right? And we want to make it much easier than all of these commands, right? Like I've done make commands and kube control commands. That's not what our customers are going to do in the end, right? Like
yeah,
that's important to understand, right? Like,
yeah. So I guess, how do we imagine kind of automating away those steps, or like what would you imagine we could do there?
Most of this can be generated, right? What did I do here, right? I ran a couple of kube control commands to deploy a couple of operators. So those are manifests that we can deploy and kick off the deployment from Terraform, from GitLab. There's plenty of places we can kick off these deployments from. I'm pretty sure the engineers are thinking about this quite a bit already. But then other things that we can do are so kicking off the deploy from GitLab, or Terraform, that's the main thing. Oh yeah, and then this thing that I went to, and when I did the auth secret and everything, that could also be done behind the scenes, right? Like, there's no reason somebody who's installing GitLab shouldn't be able to click a few buttons to say, I want this deployed, and then would fill out a form saying, this is where my Kubernetes cluster is. Here are some credentials to go there. Or if they don't even have a Kubernetes cluster, like, kick it all off with our integrated Terraform deploy, right? Like, there's no reason somebody should have to click anything and do anything manually all the way to deploy. And we know it works because we've done it before, right? Like the previous demos of Opstrace and the code pre-acquisition was like that, right? Like end to end, no human, all the way to just clicking in to login. That's the experience we want to bring back, but from GitLab, right? Like, yeah. Okay, how are we looking here? I think we're pretty good. Let's see. Yeah, we're pretty good. Look, conditions are met. The cluster's up, right? Like, that's it. It's that simple. Now we have a running cluster, but we don't have any observability to UI to go to, basically, right? Like, we don't have an instance of the observability UI running for our group. So let's start associating things. And that's done like this. So I chose this group here in which I am an admin. Okay, so I'm an owner of this. I can use this group. This is an old Opstrace group. I'm going to go to basically on local. Oh, I need to do some forwarding. Nope, no, it's running. There we go. There we go. Sorry. There we go. So again, these things are going to be nicer. This is mainly a demo, but you can see GitLab Observability is not enabled for this namespace. Okay, like usually you would not have the localhost URL, obviously, but the nicer one, I'm going to click enable. Now we're just going to wait here. This again can be made faster, but to be fair, this happens once, right? Like, you can.
So what exactly is happening in this loading sequence there?
So the loading sequence is mainly for like demo purposes and us being patient. What's happening behind the scenes can, as usual, be looked at when you look at what pods are getting deployed to the Kubernetes. And the pods are basically the pods that are specific for that group. That are only for that group, where the traffic for that group goes through. So there will be, for example, a pod deployed with the GitLab Observability UI, right? Like, not just one pod. And then there will be, like, as you see, like an operator for the tenant. So what happens basically is we have an operator that then launches another one, the tenant operator, and the tenant operator is responsible for one group, one tenant, and that deploys the rest of the stack. An OpenTelemetry endpoints, you can see it here as well, right? Like Jaeger, all the pieces that are specific to a user, or not so much a user, but a group, and are getting deployed. And that's what we're waiting on. We're waiting on these things to run, and they should be up in a second. Like, let's just wait. This is on the timer, but as soon as we have all the pods running, we'll be happy. And I think we're almost there. So Argus deployment is our UI, Jaeger is the Jaeger endpoint, and so on, right? Like, okay, should be good. Let's see, not yet. Soon. There. Oh, let's see. Like, once you've done it a few times, you know the timings. It's also, you can look at there are hints, right? When you look, and you know what to look for here. Okay, now we have this is our Grafana fork. This is still says Grafana, but that's going to people are going to be work this over. Now we're going to add, first we need to add an API key. Why do we need to add an API key? Well, let's give me a second here. We're going to call it test. There we go. That is because we are actually starting some kind of simulator here. So give me a second here. One, we don't need kube control port. We're gonna so first, this is all, everything I'm doing right now, proxies, forwarding, everything. That's just because I'm actually doing a test where I'm going to deploy a website that's emitting traces. And then I want to be able to go there and see the traces, right? So the part that I'm doing right now is a Docker compose that I'm deploying that is going to do that. So compose, this token that I just got is needed by our demo application. Oh, sorry. I'm going to start again. So token. I am still not used to all the Mac short like keyboards. Like I'm still doing all my Linux things, and then it blows up in my hand when I do use this. Okay. And there we go. We just start this up. So when we do this Docker compose up, we can see that we've given it the namespace and the token. And once this Docker compose up, it's going to create traces when I visit the website. So let's go there. First, we'll do that later. Here is the demo website. The demo website creates traces when I click on these things, right? Like basically, right? Like that's it. That's all this website does. Now we want to go look at them inside of the UI. To do that, first, we don't have any. Like if you just go to explore, there's nothing. We don't have a data source. So let's go add a data source. If you're familiar with Grafana, this is not new. Again, adding a data source is something that we're doing here during the demo, but our system will do automatically, right? Like no user should have to put a data source of something that is basically already there, right? Like it's deployed by us. Sorry, that's what I meant. Why is this being annoying? That's fine. Okay, the URL for the data source. Oh, that one is a complicated one that I need to copy paste. Where was it? I forgot about that one. It's in the quick start. I can get it. Okay, I'm going to stop. What am I going to stop here? No, I know. I'm going to create a new one. Can you still see my new screen?
Yeah, I think so.
Okay. And then quick start. And what? Oh, it's right here. Great. All that for nothing. And then data source. This quick start is available in a nice readable format, of course. There we go. There is the URL, HTTP localhost in the above group. We open. Oh, that's not the one. Where is the split up? Sorry. Says locally, because there's some other docs and how not to do it. There we go. This is the local version. This is the what I just did with all this Docker compose, and then data source tab. There. Why? There it is. Yeah, you'll see why I can't remember that one, and why nobody should ever have to remember that one, because this is really some internal URL where we have to know naming scheme and all these things. Okay. There we go. Save and test. There we go. Okay. Green is good. Explore. Jaeger. Traces. Customer. Get. And this is the click that I did at a few minutes ago. So that's a trace for the last click I did, basically, right, on the system. So you can see, and the trace is inside of the UI, it's stored in ClickHouse, and so on, right? Like, so what happened when you click here, a trace gets created, sent through OpenTelemetry, then stored in ClickHouse. Then once you go to here and you do a query, it goes and retrieves it in ClickHouse and shows it with the Jaeger plugin inside of the Grafana UI. And that's it. That's the whole show for now. Error tracking coming soon.
Very cool.
All right, I'll stop the recording.